For symmetry about the y-axis, let's consider the graph of y equals x squared. Notice that if you folded the paper, or in this case, if you folded the screen along the y-axis, the two curves would lie on top of each other. That's symmetry about the y-axis. Let's consider the point 2, 4. Notice that negative 2, 4 is also on the graph. More generally speaking, for each xy ordered pair point on a graph with symmetry about the y-axis, the point negative xy must also be on the graph. So if we have xy here, then negative xy must also be present if we have symmetry about the y-axis. For symmetry about the x-axis, again, visually, we can see that if you folded your screen or folded your papers along the x-axis, those two curves would lie directly on top of each other. That's how we know we have symmetry about the x-axis. Notice the point 4, 2 is on the graph. And since we have symmetry about the x-axis, for negative 2 is also there. And this is going to be true for any xy value. If we have xy, this is just generic value, then if we have symmetry about the x-axis, then x negative y must also be present. For symmetry about the origin, we'll be looking at this graph as a visual. This one's a little harder to envision. Symmetry about the origin is rotational symmetry. We're going to rotate this graph about the origin 180 degrees. Basically, turn it upside down, put your finger on this point and rotate it 180 degrees, and we get the same picture. That's symmetry about the origin. Notice if we take the point 2, 3, and negative 2, negative 3, they're both present. That's true for any xy value. If I choose this xy value, then there must be a negative x, negative y that is also present in order to have symmetry about the origin.